Hey everyone. So the topic of my talk is low code airflow, and I'm Sumit Maheshwari. I worked at Prophecy. I worked at Astronomer before. I worked at Twitter, Cubo, and a couple of other companies. I am part of Airflow PMC thing, I think from 2016 as well, and been involved with organizing these meetups. I think from a couple of years. Yeah, so let's move forward. Okay. Yeah, so before I talk about like what is prophecy and what I'm going to talk about what does it mean by low code airflow, I'm going to talk about what are the industry trends in the data engineering phase right now. So there's the first thing, like, we see anybody, like any company would say there's not enough talent. Maybe it's a true before this recent layoffs. Yeah, I know that a lot of people got laid off recently, so it might not be very true, but yeah, this true that, we do not have, too many folks, and then the positions are always more than the people we have in this field. And even then, let's say even a company got people, who are good, they spend quite of amount of time in doing the less productive work and writing repeated code, basically like writing repeated pipelines or the scripts or something like that, moving the data here and there, something like that, right? So it's a wasted of, like very precious resources, I would say. The second trend we see is like about the better engineering. So generally, when we talk about data, it is not the responsibility or owners owned by a data engineering team, right? It generally is something which is very valuable to the whole company. And there are a lot of different teams who want to use their data, want to generate insights, want to get, benefit out of those data. And that is what happens, that when you have so many different teams, there's very natural problem, comes around the collaboration or engineering best practices, because one team's, let's say, use XYZ practices, other team want to use ABC, something like that, right? So there's always a mismatch, and there is where the tussle generally happen. And generally, what happens that one team start dominating the other teams in terms of like what are the best practices and things like that. Also, like software engineers are generally very well versed with the gates, test, CI/CD, and this thing is not very old in the field of data engineering, right? Like recently, the data engineers have started using the CI/CD and the gate based source control and the writing tests as well. Earlier, like data engineering, it means like writing Python scripts. That's all, right? Like I know 4 or 5 years ago. So the things are actually changing rapidly. And the third trend is basically enabling the business users. So when we talk about business users, it means like the data analysts mostly, and maybe sometimes data scientists, and people who are not data engineer as by profession, but they need to use the data, they need to consume the data, and those we call like the business users, right? Who want to make use of the data. So we feel that self-serve platform is basically getting essential, day by day. If you want to, if you're not constrained by the very first point, that's fine. Otherwise, you need some self-serve platforms to help those people basically. And we have legacy tools. There are lots of legacy tools, right? And to be frank, I think most of them does not fit this category. And just a question, just that if you want to interrupt me and ask a question, do it. Feel free to do it, because I know that we hold on to our questions till the end and we forget about it. Like it happened with me every time. So feel free to ask the questions. Yeah. Okay. So when I say self-serve platform, right, what does it mean? Like what are the what are the best practices when I say self-serve platform, right? Or what is that outline it should have? So the very first thing I would say, there should be visual development. As we talked earlier in the Cloudera talk and the great talk as well, that people who are business users don't want to write the code. That's the first requirement. Second thing, it should follow the standards, right? What are the industry standards into each of different languages or different frameworks, different tools, technologies. There should be standard into each of them, and people, like whatever that this visual development is doing, it should do according to those standards. The third one is like discovery and governance. So there has to be a place to discover the things which have been built earlier by other people, and just make reuse of those things rather than building the same thing over and over and over again, right? So it comes like there are different things, like for example, lineage is one of that I would say aspect. Search is another one. Access control, of course, I don't want to build something for say data science used by something into machine learning, something like that, right? So there should be access control. And of course, I would like to publish, I would like to subscribe. All those things comes under discovery and governance, of course. And then comes the optimization. I want that my platform to be very optimized in terms of performance, in terms of cost. Because if I let somebody write something which he or she is not very used to, they might write something which is not very performant. Either it would be like having cost performance, either they would have something bad, right? You know, sometimes I've seen people initially using Airflow, they would say schedule date like 2016 first Jan, something like that, right? It would just fill out everything. It was in 2016-17 experience. Sorry, 2016 or 2017, it used to happen quite a lot. And last part is like about deployment and scheduling. There has been, there has been a teams just to do the deployment and just to do the scheduling, right? There are people who take the code, build it, deploy it, something like that, right? So we do not want people to waste their time into those mundane things which should be get done automatically, something like that, right? So I should be able to write I should be able, like whatever the code is got generated, it should be testable, it should be source controlled, it should be, there should be part of the CI/CD, and it should be scheduled, or like it should be deployable, right? And yeah, and I think the last very important part is that this self-serve platform should be sitting on top of your data platform, right? So data platform, like all companies, you are all right, already know, right? There is a compute, there is a catalog, there is a data. So this self-serve platform ideally be sitting on top of data platform, and whatever you are having right now should just work as it is. Like whatever data platform you have, it should be fine, but this platform should be on top of it. Yeah. So here comes the prophecy. So prophecy has basically a low-code platform, and it has some unique, like prospects into it, right? So the first one is basically that the ease of use, basically, and the productivity and the rich feature set from the visual development, right? So prophecy has a very state-of-the-art visual development kit, which can basically which let the business users or data engineers or data scientists to write their pipelines or write their code in a very neat fashion, basically, into very niche quality, I would say, right? So they have standardized a lot of things. They are able to reuse the things which you like somebody else is writing. You can do search, you can do you can write a test. You can do also generate the lineage as well from there. And the second point, another main point of prophecy is that it writes or it gives you 100% open source code. So there is no vendor lock-in at any level. Okay, whatever the code you're generating, we do not say that it has to be run onto Databricks or EMR, or it has to be run on Astronomer or AMWA, or it has to be run, or even we don't say even that this code needs to be run via prophecy. You can take the code, and even you can, because the code would be in Git, right? So you can actually deploy it anywhere, wherever you want. And the ability to write new abstractions, or I would say like new code components. So it also enables you basically to write or create new, we call it kind of app builder and framework builder, basically. So you can go and write or create new set of components, visual components, which actually generate the code, and that code be like ideally be very efficient, because you would be putting your best brains to write those code, because those guys who are like very good at writing, say what those kind of jobs, would be writing it, and then other people are just using those pre-built code or pre-built components. Yeah, thanks. So we say that the low code is the foundation to move forward and to move fast. And we say that with this thing we can enable 10 times more users, and with the 10x more abilities, basically, like, or more productiveness, I would say. Why I said so? Because when you onboard a user into your traditional platform, you have to guide through all sort of best practices to write a Spark code, or best practices to write a Airflow code, and whatever you're using, basically, right? You have to kind of go through that. You have to maybe like make them aware about the CI/CD, Git, test, lineage, so many different things, right? And then only they will be able to write decent code. But with this, but with this platform, ideally you should be able to do it like right away, maybe within a day, something like that. And your business users just able to write, just able to use it and get the what they need. Uh, so yeah, I think this is like a standardized visual development kit, right? And then reuse the visual blocks. I think those are the two main things I would say. Yeah. Thanks. Yeah, I think the another important aspect of the software development practices is that getting that open source code or 100% open source, I would say, like there's no vendor locking involved at all. So the code it generates is basically very high quality and I would say industry grade code in whatever things you are generating for Spark or Airflow or for DBT, let's say, right? So those are like the industry standard code. It has very it produces a test coverage as well, which is actually quite sufficient to start with. But of course, you have the capability to even write more tests and things like that. And of course, we by default from the starting point itself, we integrate ourselves with the Git and CI/CD. You don't have to figure it out later on. Oh, I wrote the script. Okay, I deployed it. Now let me figure out how I put to you how I use Git or CI/CD to use it, right? So we do it from the start of the whole engineering process or for whole software development process. Yeah. Okay, and here comes the reuse part, right? When I think I'm keep talking about the reusability of the code and reusability of the component. So we feel that, or I don't know, like how many aware that in the Airflow, there's always philosophy that we prefer code over UI, right? That has been the mandate from the day one, right? And we also agree to that. And we feel that, okay, even though UI enables people to move fast, right? Do the things, but we cannot get away from the code. And how to solve that problem then, right? We want to solve the problem in the other way that we want to let people to write reusable components or reusable code components that can be integrated with the other users' pipelines. So this way, we are actually doing the best of both worlds, basically. Right? We are giving a UI development kit as well as we are giving a reusable and testable code as well. So here it like you can basically you can like go to the UI, you can able to create new gems and you have to fill out some basic details and then you're able to generate the code out of it and then anybody can use those code components which we call gems internally. Yeah. Okay, so here is very high level architecture of Prophecy. So this is basically okay, so I will like start from the top, right? So this is where your users would interact, like your business users or data engineers or other engineers would interact on the top layer, right? They would actually develop interactive visual pipelines, which means that actually they can while developing itself, they would be able to see the output in each layer, like in each component they could see what is the input, what is the output, how the transformations are working, how the aggregations are working and things like that. I will try to show into demo as well. And like other perspective, like deploying to Git, test, CI/CD, manage. You can manage like the lineage, data quality checks as well, even integrated. Cost thing we are not yet there, but ideally you should be able to even manage the cost while developing the pipeline itself. And last is like extend. You can extend this whole thing like by creating the new components. Then comes your existing data infrastructure, like this layer. So we generate the code, we push it to Git, like which is of course your company's Git, right? It could be a Scala code, it could be Python code, it could be SQL or DBT code, right? If it is, and we do not run any of these things onto our side, right? So everything is basically every code we run or like suppose like you're going to run is basically on your side of it, right? So for Spark, we actually integrated very seamlessly with Databricks and we integrate with the EMR as well or Dataproc or I think SD side as well. So these are basically what are the Spark vendors available in market, right? We integrate with all of those things. Maybe Cloudera will come in future as well if the customer demands. For deploying Airflow, we integrate with the Airflow, of course. Like that, this Databricks also is a very trimmed down version of scheduling things, which is not as extensible like Airflow. So that is why we recommend to use Airflow. And for Airflow, we do not run it our own. So we use something we can actually integrate with say Astronomer or Google Cloud Composer, or unfortunately with MWA as well. Yeah. So, and if you're working on DBT, right, then we can actually work with Snowflake for now. But I think there are plans to actually integrate with other like I think BigQuery as well in the line, and maybe some more. Right. So that is high level architecture of Prophecy. Yeah. So I think this is the like this is how to get a start, right? So basically, as I told, Prophecy runs on top of your existing data platforms. It can connect to Airflow, Spark, or your SQL data warehouses. We are actually we work as a Kubernetes operator. So the deployment is very flexible. Basically, you can actually deploy into public SaaS and as well as private SaaS or on premises as well. And there are other Spark and data warehouse integrations are also coming soon, basically. And yeah, I think that's it. Okay, so let's pray the demo god that things work fine. And so okay, basically, so this is the UI, right? So this is basically when you land to the Prophecy, you will see a UI like this should be the ideal UI, right? And then there is a course, like there is the guidelines, there is a documentation about how to start and all those things. But I'm just going to talk about something called pipeline. And I also have a say that right now this pipeline I'm going to show is about how we write the Spark code and run it onto Databricks, because writing something for Airflow and running onto Astronomer or MW or Composer is under progress. It's still being worked, but this meetup came up early, so we just thought, okay, yeah. So maybe like I think a couple of months, maybe 1 or 2 months down, we should be able to write Airflow code, generate Airflow code from it, and run it there as well. So basically, you can actually create new pipeline as well, and then do the things. But just to save the time, I'm not going to do that, and I'm going to open something like existing pipeline, and then let's just walk you through very briefly about it, because I don't be able to do the justice in couple of minutes to give the full capability of the platform, right? Yeah. So yeah. So basically, what you see is that here in the down, in the down, it is basically connected to a Git, from the start, and we something called, we have different sources, like, so you can actually configure it like from where you want to get the data. We have different formats, different supported things from where you want to actually get the data. What is the location, and what are the properties, basically. What is the location, what are the properties. You can actually add all kind of properties depending upon the data sources and depending upon the location. So if you are loading from Delta table, or if you are loading from say Redshift or Snowflake, the properties keep changing, right? So this UI is basically is keep changing, and then it will give you nice preview about the data, and you can load the data here, right? And then basically you can have one or more different sources. This is very small pipeline I'm showing you, but I have seen around like more than 100 nodes such like this with the customer's environment, right? So yeah, you load the data, right? And then you can do the different type of transformations. So we have whole bunch of transformations, like you can do filter, order, different things. So I'm doing like a join here, and then you are basically then you are again doing aggregates. So these are basically different type of transformations. So aggregate is one of them. There are different options to aggregate the data, group by, or a normal aggregate. You can actually reformat the data. And basically the target is basically like where you want to save the data, in what format you want to save the data. So for example, I want to save the data into CSV format, that would be my location, and what are the properties I want, depending upon the CSV format, and what are the fields I want to store. And yeah, once that is done, you just need to actually attach a database cluster from here. And if you are working on a say EMR, you can attach the EMR cluster from here. And once it is done, right, you can actually do a run from here, which I'm just going to do actually, or otherwise there's another option. You can actually at each step you can actually run that step as well. So at each step you can play that individual step and see the outputs as well. But for now I'm just going to run this whole pipeline, and we call it an interactive mode, because I'm interactively submitting the pipeline for the execution. I think another step I forget to tell you that this gives you the code here. So what you see is basically is quite performant Spark code, generated by Spark code, I would say, generated, and that code is basically bundled as a jar and then send it to Databricks for the execution. So this whole code, what you see, is also available into your Git. So Proficiency do not hold your code. This code is available into your Git. And yeah, like coming back to here. So what happened? These first two steps are done, and they also got me interims. So we call it interims, are basically the internal results of the data, right? And you get. I think actually I moved to the code, so it got stopped in between. I can run it again. So this interactive basically, if you move away somewhere, it will go away because you are like supposed to be running like interactively, right? So yeah, this job is basically executing at Databricks side, and if you were to see, all the overall states, overall progress about it, and if you open Databricks UI, you will be able to see as well, like how the job is going on, like what are the different stages of Spark is going on, and things like that. Yeah, and I think that here is the part I'm talking about, like the schedule. So schedule is basically something where you can actually schedule this job. Okay, and when I say schedule, it means that whether you want to schedule into Databricks itself, the Databricks gives you a very trimmed down version of scheduling capabilities, but Airflow gives you much more, right? So, and Airflow we do not have right now. So right now you can schedule into Databricks. You can provide the interval and all those things, and these jobs will basically get scheduled to Databricks, and something like this will start appearing that this job is the scheduled job. You would see that what are the interval, what are the last runs, and if you click on it, like it will show what are the runs. So the same thing would happen with the Airflow as well. You submit a job to Airflow, the Airflow will job get deployed to Astronomer or MW or Composer, right? And then you come back to Prophecy, you will see that okay, this job I have scheduled, and this job how it is running into whatever the cloud vendor is. And yeah, anything else? One second. And yeah, I think another important part I forget to tell you that when you create a job, you can actually drag and drop multiple pipelines into it. So what does it mean? That whatever I showed you, that was a one pipeline. Okay, but for example, I'm deploying for Airflow. So what I can do is that I can drag and drop couple of operators, the Python operator, base operator, email operator, Slack operator, whatever, right? And then I can also import those pipelines which I wrote there, because that is a kind of a single entity for me, right? So I can actually create a very big pipeline as well. So it's up to us, right? We can actually, we want to mix and match multiple pipelines. Then we can also drag and drop, and we can also use the multiple pipelines. For example, here I can actually add a pipeline. I can add another pipeline, and basically this Python script is here. So they are all actually dependent upon each other, and then I can just join them. And what is happening basically this code. So if you look at the Airflow side, it would show you one Python operator, and the downstream there would be two operators. Those would be for this case, it would be like Databricks operators, and the whole code to run the Databricks pipeline, which I showed you earlier, would be bundled into a jar. So similarly, you can actually include more pipelines, and more operators are also coming soon. Over the time. So yeah, I think for the first very release, we have a very basic operators like Bash, Python, branch, and a couple of small ones. But the good part is that you don't have to wait Professor to build those operators for you. You can, like for example, in Crane's case, right? They want to build a new operator for Databricks, something like that, right? So they can use our code builder and write a new operator, and that would be available as well for them. If suppose the Crane is a customer, they could write their own operator and they can use it. They don't have to wait for anybody else to write those operators. And anybody else who's using within that company, they can use the same operator which these guys wrote. Make sense? Okay. I think that's all about the demo. And yeah. And yeah, that's a shameless plug. We are hiring. Don't apply directly. Come to me, talk to me. I will earn some referral. That's all. Right. And thanks. That's all. And yeah, of course, any questions? I think we have 5 minutes before the next talk. Yeah.
So, smart airport now we can clearly define differently the last step and the right last. Smart term how you will say, what are the steps when you're generating smart code, right?
Yeah. Sorry, I did not get your question. Like,
You create a pipeline.
Yeah.
One step depends on 3 or 2 steps before.
Correct.
How are you generating it in the smart code? So that
Yeah.
more than not before.
Right. So yes, so what we do in Spark, that we once again let me open that. Yeah, right. Once again, so I think I was showing you this pipeline. So if you go to the code view. Okay, this is showing the Git code actually. Let me open that pipeline itself. Actually, they're both the same, but I don't want to go to Git and view the code. Okay, so when you open, when you write a Spark pipeline, right, what you see is basically all the Spark code. It is a PySpark. You can write in the Scala as well, right? So you can see different, different entities basically here, and we're asking about the wiring, like how they are wired, and the wiredness is basically their wiring is coming from here basically. So it's a, I would say it's a internal to prophecy that how we do this wiring. Basically, this is a whole workflow.json, which actually tells the UI and also the code generation utility, like how to wire those, those things basically into each other. So this is how what basically wiring it, like input and output and things like that.
Like airflow for the smart code, all the sequence, 2 tasks, they can't run parallel.
No, I think they can run, right? It's all about the executors, right? So if you have like, see, the code will submitted into executor, right? And it will submit the code in such a way that, if there are 2 parallel steps, those 2 steps will go like, they will submit it to Spark executor, right? And then third step, which is dependent, it won't be submitted until the first 2 got done, something like that, right? So yeah, of course, it can run parallel things, not an issue.
Let's say a customer comes, makes a modification, can they re-upload their page back into you because
well, right now, I think what we have is that we have immutable gems basically. What does it mean that, sorry?
have to use the gems that
Yeah, actually what we do is like, I can just show you that we have actually our gems and custom gems as well. So what does it mean that there are prophecy defined, prophecy provided gems, and these are custom defined, which are basically user defined gems, let's say. So these gems are not editable, right? So once the code is generated, it's like locked, right? So if you want to change something, and I think you have to kind of, let's say, copy it and then create a new gem and make the changes and then use something like that. Yeah. So there are prophecy provided which are by default get loaded, and there is also user defined, which is basically custom gems which users basically load, and basically you can use both of them and do your pipeline. Yeah.
sorry, one same question. So your entire is a subscription based say pay months per entire year.
I think we have a user service, like per user based pricing. I don't know exact details. I just joined in 1.5 months, but I think which cost I think per user, or maybe like lump sum cost as well. Like, okay, like I want to use for 1 year, like what is the cost, something like that. So I believe it's a per user cost only. There's no cost in terms of the number of pipelines you write, in terms of database jobs you submit, or how much database compute you use. Nothing, like there's no pricing at all. Like it's about just the user based pricing. Yeah. Any other question? Quality frame. Because quality features given. Yeah. So the quality, I think what we do is right now, I think I don't have it yet in examples, but what we do is basically, let's say after one step, right, you can actually drag and drop another gem which is like related to quality, right? And then you can put your configuration about the quality, like what is number of user expecting and things like that, right? So in the pipeline, you will see like 4 or 5 gems, right? And then after you put another, just before the target, you can add another gem, which basically makes sure that quality is like, it's adherent to that the pipeline output, like what is supposed to be doing, it's doing or not. I think I don't have that example right now. But I think it could be available in docs or somewhere as well. Yeah. And I think it also generates the test cases as well, which I not showed, but it generates some, basic tests as well. And then, yeah, you can actually write those, you can fill out those details as well in those test cases. Huh?
Profile.
Uh, sorry, profile?
Data profile.
Not data profile. I'm talking about the, like the,
Test case.
yeah, test case about the pipeline itself. Yeah, yeah, right. Great. Okay, if there is no question, I think, we can wait and see, we can wait for the next. Oh, yeah. Cool, I think that's it, right?